Yeah, so one uppercase letter, which will kind of imply maybe one lowercase letter as well. At least one.
One number, one special character.
Yeah, at least one uppercase letter. At least one lowercase letter. No spaces. Sometimes they say you can't use your, name or email address in them, but we're going to kind of skip that one. One number, yeah.
Minimum character strength, yeah.
One special symbol, which is a non-alphanumeric character. And non-alphanumeric, alpha means alphabet, numeric means numbers, so that means punctuation, pound signs, question marks, and stuff like that. Minimum length, 8 characters, 10 characters, something like that.
Maximum length.
Pardon me?
Maximum length, usually no more than 16.
Yeah, maximum length, although it's cheesy to assign a maximum length, because what if you want to be really secure and feel like typing in, the Book of Job as your password? Why not? But anyways. All right. So to do this, we're going to write a program that will ask the user for a password, and then we need to determine how many uppercase letters there are in it, how many lowercase letters, whether there are any spaces, whether there are any digits. I'm going to change the word number to digit. Whether it's got at least one special character. So to do this, we need to know how to inspect a string. Now, we talked about lists on Monday. In effect, a string is just a list of letters. I should say characters, because, digits and spaces and periods and stuff like that can all appear inside a string. So going back to the concept of a list, let's refresh our memory. Just stay in the Python shell for a moment. Make a list called L for list. And let's put some numbers in it. 8, 6, 7, 5, 3. Guess the last two numbers. Come on, you fans of 80s rock. Nobody? 8, 6, 7, 5, 3. Okay, anyways, there we go. There's our list. Now the way lists and arrays, array is a very similar term to list. Python doesn't use the term arrays, but Java and C and C++ and C# and a lot of other languages do. The way that they are indexed, if you want that position, what is this position number? What is this index number?
The 8?
Yeah, the very first one.
It starts at 0.
That's a 0. It's called zero-based indexing. So that's position 0, 1, 2, 3, 4, 5, and 6. Since it's a phone number, it's 7 characters long, 7 elements long. So you can always go from 0 up to the length -1. Why don't we check the length of it? Length of L. Let's print L 0. What's a quick way of getting that last character? I could do it like this, but this is kind of cheesy. Since Python offers us the option of doing this, that would get me that 9 if I didn't make a typo, but there's a far easier way of retrieving that 9. Right, Python supports negative indexing, where you start counting from the back of the list. So 9 is -1, that's a -2, that's a -3, and so on, all the way up. So L -1 is going to be the 9, the last character. If we want to take a subset of the list, we could do that with slicing. Subset meaning, a part of the list. Like I forget what the first three digits of a phone number are called anymore. Not the area code, but the other thing. But anyways, I'm going to make F for first three. Is equal to starting at position 3 and going up to, but excuse me, starting at position 0, going up to but not including position 3. Well, what do you know? That's because I forgot to specify the list. F is equal to list 0:3. And then print out F. So that gets the 867. It'd be neat if there was a syntax that would then let us get the rest of these easily without calculating the length of the list. And as a matter of fact, there is. If you leave off something either in front of the colon or after the colon when you're taking a slice, it means go all the way from the beginning, like 0. If you leave off that 0, it just assumes a 0. Now that's not so great. I mean, you could have typed that 0. It's not that hard to type a 0. But if you put a number here in the first one and you put the colon, but you leave off the second number, it goes to the end of the list, which is kind of nice. You don't have to calculate the end of the list. So, for example, if we do L3 colon and don't specify anything, it's going to go to the end of the list, 5309. If we do L colon 3, it's going to get the first 3 characters of the list, 867. So you see how that colon works? If you leave off the number in front of it, it assumes it's a 0. If you leave off the number at the end of it, it assumes it can go all the way to the end of the list. Technically, the last number is filled in with the length of the list, which in this case is 7. Let's go ahead and type that. Starting at character 3 and going up to the length of the list, but not including it, we get 5309. Why is that? Which of these digits is position 3? Well, I mean, it just printed it out, but that's 0, that's 1, that's 2, so 5 is at index 3. And then going up, but not including index 7, if that's 3, that's got to be 4, that's got to be 5, that's got to be 6. What's the easier way for my brain to think about that? Subtract 7 and 3, you get 4, so starting at index 3 and going 4 characters. My brain doesn't really work nearly as well when I'm trying to go up to but not including, but I can take the difference between two numbers and say, oh, it's going to be 4 past that. Strings are the same way. Can I start a new shell? Restart shell? No, that's not going to do it. I don't care if you all start a new shell, but I want to. What I did is I did File New, and then I closed the shell so that I could reopen it. You don't need to do that. I just like my stuff to be at the top of the screen. Okay. Do in, let's do lowercase n, and put a name in there. Tony Stark. Whatever. So, in position 0, what's that going to be? T. In position -1, going to be the last letter. K. What if we do something like this? Character, or CH, is equal to N0. Now we want to test that character to see if it's uppercase or lowercase. Fortunately, there are functions that do that. If we go out, check our contents, there's a Unit 2 notes. It's got Python string methods. If it would let me get that. Maybe I can just get it from here. Okay. Here they are, although they use S dot. You know, you would use whatever your list or your string, excuse me, whatever your string's called. In this case, I called it CH because I just got one character out of it. Is alnum returns true if the string is all digits. Is alpha returns true if it's all letters. Is upper indicates true if it's an uppercase letter. Let's play with a few of those. Go back here. CH dot is upper. And since it's a function call, or more technically a method is a function that's attached to a variable like this. True, it is an uppercase letter. Let's print out CH just to remember what we're working with. In my case, it's a T. If you typed in a lowercase name, that's not going to be true. So if I type CH dot is lower, it's going to say false. That's because that capital T is not a lowercase letter. CH dot is alnum. That stands for alphanumeric. Is it a letter or a number? Yeah, it is a letter, so this is going to return true. Let's check to see if it's a digit. CH dot is digit. Well, is it a digit? Not in my case. My name didn't start with a number. False. All right. I think we have most of the things we need to see you could check to find the specific position of a character in that name. I have a space in the name. So if I do name.find and I look for the space, is this going to be an error? It's at index 4, which is true. 0, 1, 2, 3, 4. So I could do in.find. It'll return the value or it'll return a negative value if it doesn't find it. What if I'm curious, like, is there an X in it? X in? Whoa. Sorry. Quote X in. False. There was no X, the letter X, in that string. Let's go ahead and create our file now. Let's just do some sample stuff before we actually start working on the password idea. So make your new file, save it to your favorite place, call it stringy or something like that. Let's make a string. Put some letters, numbers in it. Maybe a period. Now those methods I showed you will work for something that's more than one character long. We could check to see if that thing is composed entirely of numbers. If n.isDigit, print, yep, all digits, else colon, print, nope, not all digits. Now I put a mix of things in there. So if I do is alpha num, it's not going to return true. If I do is alpha, it's not going to return true, you know. So perhaps I should have made my string a little bit more selective. I could go back in there and change it to something that was all digits just to make this work. Nope, it's not all digits. Sure enough. I'm going to change my string so that it is all digits. Then run it again. Yep, all digits. I'll make a new string. It's going to be all letters. Bob. If s dot is alpha, which means alphabet characters, print, yep, all letters. else colon, next line, print, nope, not all letters. What do you, if we want all special symbols, there is no is method for that. But there is if alnum, which returns true if it's all letters or symbols. And we can kind of reverse that, because if it's not a letter, alnum returns true if it's all letters or numbers. And so if it's not a letter or a number, then it's a special character. So let's try that. First, let's do is alnum. If s dot is alnum, colon, print, it is all letters or digits. Else, colon, print, nope, there are special characters in it. But we might want to reverse that logic. Maybe we want to check to see if there are special characters in it rather than that being on the else end of things. So we could do if not s dot is alnum. That not reverses. Stephen Colbert always talked about the truthiness. Reverses the truthiness of this expression. If that returns true, then not is alnum is going to return false. So we're going to do, if not is alnum, we're going to say, yes, special characters. Else, colon, print, no special characters. Now, since it's the same string, we ought to get the same kind of output, from this one and this one. If this one says it's all letters or digits, it ought to also say no special characters. If this one says nope, there are special characters, it ought to say yes, special characters. Right now, it's just all letters. So it's not going to be surprising that it says that it is all letters and digits, no special characters. So I've gone back and I've added s comma as the first part of each one of these print statements, except for the first two. I could put n comma on those. Is this strictly necessary? No, but when we run it, we're going to appreciate that 1, 2, 3 is yup, all digits. Bob, yup, is all letters. Bob, it is all letters or digits. Bob has no special characters. Then when I go back and I change this to question mark, exclamation mark, period, we should see, yes, there are special characters. Nope, it's not all letters. That kind of stuff. So we can use these functions, these methods, to build up a count of how many digits there are, how many uppercase, how many lowercase. Now, I didn't demonstrate is alpha. Is upper and is lower. Can we take it on faith? Let's do this. Print s comma is upper. That'll just print true or false, whether it's all uppercase or not. But it doesn't tell us whether it's uppercase or not. That's kind of dumb. So I'm going to change that print statement a little bit. Print s comma upper question mark, or is upper question mark, followed by s dot is upper. Like that. That's a short form of writing these if statements, just to prove that it works. Also helps if I put commas in the right place. So obviously that is not uppercase letters. If I go back and I change S to B-O-B, make sure it's all uppercase letters. Bob is upper, True. Copy that line, paste it, and change the word upper to lower in each place. And I know that we have at least one person who may need to leave early. Oh, it's not you. If so, I'm going to go ahead and make a Dropbox for this. I think that's about enough. I think with this information, we can check to see if it matches all the rules. Can we check for uppercase letters? Sure. Can we check for lowercase letters? Sure. Can we check to see if it's a space? Well, we didn't check to see if there's a space. Let's go back to our Word document. What do you know? There is one called is space. Why do that if you could just do is character equal space? Well, this would check to make sure the entire string was spaces or not. Because if you just did equal space, it'd only check to see, it would only match if it was one character long. Also tabs. Tabs count as space. Even hitting the enter key counts as a space. You could put any one of those things. So we're going to tack one final one onto our stringy. Copy one of these last two and then change it to say is space. And heck, let's actually change our string so that it's all spaces. There, just like that. I went back up and I changed S here to be all spaces, just so that I could see something down there. Say true. Now when we do this stuff, we're not going to want to check the entire password. We don't want to know if the entire password is digits, or if the entire password is uppercase or lowercase, or if the entire password is spaces. We want to just pull out each character at a time and test them. Let me run that, make sure it works. Yeah, is space was true because in fact our string is all spaces. So it's time to actually create our password program. I'll kind of leave this part on the screen right now, but actually I hope that y'all are done typing on stringy. If not, maybe we can print it out and you can do it at the end. So what do we need to do? My name, the date, password, checker. What does the program do? Ask the user for the password to check. Make sure it follows these rules. What's our minimum length going to be? 7, okay. Length at least 7. No spaces. How many numbers are we going to require them to type in? 1, 2, let's just do 1. At least 1 digit. At least 1 uppercase. I'm going to shorten that to just upper. At least 1 lower. And by abiding by these, we've kind of set up another implied subrule, which is that it's got 2 letters in it. You know, it can't all be numbers. Because if it's got an uppercase letter and a lowercase letter, obviously it has at least 2 letters. Were there any others on my little cheat sheet over here? Oh, and at least 1 special. I'm going to say non-alphanumeric. Fancy term meaning it's not a letter or a digit. Punctuation, that kind of stuff. Now, to my thinking, a space might be a non-alpha. Let's find out. I'm going to go back to the shell and find out if a space is alphanumeric or not. This syntax looks crazy, but it actually works in this language. Quote, space, quote, dot, is al num. Isn't that crazy? But yeah, it's saying that that's a special character, that it's not an alphanumeric character. But that's not going to be one of our allowable alphanumeric characters. We will have to rule that out by checking for spaces. Alrighty, we listed all of our rules here. I don't particularly care if you type all those in as part of the in-class assignment, but this is also going to be a homework assignment, and so I do want you to go back and add the rules. They'll be posted, pasted into the Word doc, the PDF. All right, so what do we need to do first? We don't need to do any imports, so ask the user for the password to check. What do we want to do our input password stuff down here? Do we want to display a message? Do we want just a blank screen where they have to guess what to type in? What do we want to do?
Display a message.
Yeah, let's display a message. Print, enter new password. And then password is equal to input. Now do we need to call float or int? We've been doing it every other time. No, because this isn't a number. Or at least we hope it's not. Alrighty. Now there is more than one way of stepping through a list to get out each character. We're going to probably wind up deleting some of this code, but I do want you to type it in. Method 1 is using an index counter. We could use a while loop. We could use a for loop. A for loop is just a fancy while loop. I think I'm going to go ahead and use a for loop this time. For x in range, starting at index value 0 and going up to but not including the length of the string, the length of password, I tell you what, I want to type the equivalent while here. Don't type this because I'm just going to delete it. But this is the same thing as doing this. X is equal to 0 while x is less than the length of the password, x plus equals 1. This one statement here replaces all of that. What range does is it returns a list of numbers that start from the starting value specified here and go up to but not including that one. So if our password is 10 characters long, this is going to be 0 and this is going to be 9. That's important because if you try to access value 10, that's actually past the length of the password. Okay. Hope the for loop isn't throwing you for a loop. No pun intended. I actually did not mean to say that. Let's just print out the letter at this point. Or let's get the character out. CH is equal to password at that specific position. And then let's print it out. I didn't save this one yet, so save it and call it password. Now when we run it, it should ask for our password and then it should type it in one letter per line. Well, what do you know? That was dumb. What did I do wrong there? Why didn't it print out my password letters? I heard somebody start to say it.
Did you print index instead of NCH.
Yeah, I'm printing out the index counter itself rather than the letter we just got. Okay, so that part is working. We have proven that we can get a letter out. And then we could test that letter to see if it's an uppercase letter or a lowercase letter and all that kind of business. That's one syntax for getting stuff out of a list. Remind me, on Monday when we were printing lists, did we do it like that or did we do something more like this for CH in password? Which one of those syntaxes did we use? Did we use a while loop kind of approach like that, a while, or did we do that? I can go back and look.
You did while with it greater than.
Okay, all right. This is a simpler syntax. I'm all for simple. For every character in the password, print out that character. Okay, if you had a choice and we're on a time crunch, which one of these two loops would you rather type in? The second one is cool. There is a possible side effect of using the second one, but it doesn't apply to strings, which is that CH is just a copy of the data. So if you try to change it, it doesn't change it in the original string. But to be honest, in Python, strings are, quote, immutable, meaning they cannot be mutated, they cannot be changed. You can create a new string, but you can't change one letter in an old string. So that particular caveat, that particular drawback of using the second syntax doesn't apply here, but it does in lists. If you wanted to change every value in the list as you step through the loop, you would not use that second syntax. You'd have to use a while loop or some other form of index counter. Now I know what's going to happen. On the exam, I'm going to ask you to write a loop to print out a list or something like that, and you're going to get your wires crossed. You're going to mix up the syntax for a while loop, or in other languages, this is called a for each loop. Some of them even use the word each. I kind of wish that Python had. And it just says, for every item in the list, do something with that item. So it doesn't use indexing at all. We see no square braces at all in this fashion. So this is an index counter loop, and this is a for each loop. I do give half credit on the exams if you combine the syntax, but it's not going to work. If you type something like this, for CH and password, print password X, that's not going to work. Why? There is no X. So this is the simplest one. It's actually kind of the one I'd like for you to memorize the most. Now, do we really need to be printing this stuff out? Not really. So comment that first one out. We don't need to print the password twice. What we do need are counters. How many spaces are in this password? How many uppers are in this password? How many lowers are in this password? And so on. The source code for the homework, I'm going to paste this into it so you'll be able to just get the whole thing. So let's add some counters. We have to declare them before we start adding to them. Spaces is equal to 0. We're going to check to see how many spaces are in it. Specials is equal to 0. Uppers is equal to 0. Yeah, we're going to need the rest of them, but I'm not going to put those in for now. And then we will handle length at the very end of it. So I'm not going to make a separate counter for length. Why? Because it's real easy to get the length. You just type in len and then the length of your list variable. Alrighty. If ch dot is a space, colon, and there's two s's in is space, then the number of spaces gets increased by 1. Now I could use elifs, I could not use elifs. I'm just not going to bother. Won't hurt it. If ch dot is upper, parentheses in parentheses, add 1 to our number of uppercase letters. Kind of see what this is doing? It checks every letter in turn. If it's a space, it adds 1 to that counter. If the whole thing was spaces, you know, the spaces counter might wind up at 10. And then there would be no upper letters. You know, uppers would still equal 0 because it never got to this statement. And specials, the slightly harder one to write. If not, ch dot is alnum, colon, then that means it's a special character because it's not a letter or a number. So specials plus equals 1. We're going to go back, or your homework assignment is going to be to go back and add some extra stuff. But that's enough for now. We could make it print those counters out, or we could just use an if statement. I like the idea of printing them out. Print spaces equals, comma, spaces. Print specials equals, comma, specials. Print uppers equals, comma, uppers. That's just to make sure it's working. I'm going to type in something that's got some spaces and uppers and specials and make sure it counts them right. Get over there. So my password. Hi, 2 uppers, 1, 2, 3, 3 letters, space, and then some exclamation marks. I didn't check, yeah, I did check for spaces. This isn't actually counting the number of digits yet. That'll be an easy fix. How many spaces were in it? Yeah, there was 1 space. How many special characters? Well, it actually counts a space. That might be a good point to do an if else, but nah, we're going to leave the logic as simple as possible. So far, Anna had 2 uppercase letters. So far, our program seems to be working. We need to put some if statements down at the bottom. If spaces is greater than 0, print an error message. If specials equals 0, tell them that they needed to add some special characters to their password. If uppers equals 0, tell them, nope, you got to have some capital letters. If I was documenting this program as I should put a comment here that I'm counting, you know. I think I'm not going to actually do that. But I am going to put a comment down here to say, check if password is valid. So I'm going to make a variable called isValid, and I'm going to set it equal to true. You probably didn't do that, but that's okay. You can go back and change it once you do. So if spaces is greater than 0, colon, it's not valid. Is valid. Oh, by the way, that true needed to be false. Excuse me. That true needed a capital letter. Just in this language. I'm going to tell them it's not. Well, we're going to set. That's what's known as a flag. If you have a true-false variable, more technically a Boolean variable, that serves to tell you whether something is good or not, that kind of thing, that's called a flag. You can have error flags, that kind of thing. This is kind of going to be our error flag. If it's set to false, it means we have a problem. And then we're going to print an error message. Print password must have no spaces. I'm going to stop that if now. So I'm going to unindent. If uppers is equal to 0, it's a problem. Is valid equals false. You may have been tempted to use elif or elsifs. That would also work, but it wouldn't tell you everything that was wrong with it. It would just tell you, the first thing that it found that was wrong. That's why I'm choosing not to use elifs down here. Print password must have at least one uppercase. If you feel like shortening those messages a little bit, that's okay. And then lastly, the specials. If specials is equal to 0, is valid equals false. And then at the end, we're going to just print out is valid, because that'll tell us whether it's a valid password or not. Print password must have at least one special character. Well, a Z is special, isn't it? No, not in this case. Then lastly, we're just going to print is password valid, question mark, comma, and then that is valid flag. So it'll print true if it's a valid password. It'll print false if it's not. So we're almost done for the day, but there's one more thing that I want to do. And yeah, I know some of y'all are working ahead to actually complete the rest of the rules. That's okay, but we're going to take a side step. As soon as everybody's got this much running, we're going to write a function that will count the number of digits or uppercase letters or something like that. It's a different approach, but it would work. Enter new password. Hello, exclamation mark. It says password must have at least one uppercase. Is password valid? No, because it didn't have any uppercase. It would be neat if we made this loop. Just consider that for your homework. Loop until they enter a good password. Enter new password. I'm going to go ahead and type in an uppercase, but I'm not going to put any special symbols in it. It says, is password valid? False, because it must have at least one special character. As I look at this, this thing is producing a lot of extra input. It is noisy code, not input, output. Do we really need it printing out every letter? Do we really need it printing out these counters? No. When you get done with your program, if you feel like going back and removing all the prints that make this look messy, because really all it needs to do is say enter new password and then give the error messages and then tell you whether it's valid or not. The rest of the prints are kind of extraneous. They're good debug information. So let's create one more script. And it's going to be very simple. Let's just do a count spaces. So we're going to do DEF count spaces. And it's going to accept a string as a parameter. And then down here we're going to write another one called count specials. Nah, count uppers. Is this directly part of your homework? No, but I want you to have the concept down. We're going to do the same thing. We're going to have a counter, and then we're going to run through the loop, and if it finds any spaces, it's going to add one to that counter. So x is equal to 0 for character in S. Now, is there something incredibly important about using CH? No, it just makes sense to me. You can call it Fred if you wanted to, or letter, position, something like that. I wouldn't use position, that implies an index value. So if character dot is space, add 1 to x. And then at the bottom of this, return x. Whoops, not caps though. Our count uppers code is going to look exactly like this, except it's not going to call is space. Best way to do it would be just to copy those 6 lines, paste them, and then change is space to is upper. If we did it that way, it'd be really easy to write the rest of these, is digit, is whatever. So now let's ask for a string. We could just call it password again. Password is equal to input, quote, new password. And we're not going to do the whole thing, but we're going to do this. Spaces is equal to count spaces, passing that password in. Uppers is equal to count uppers, password. Then let's just print those things out. Spaces equals, comma, spaces, print, uppers equals, comma, uppers. Call it password 2 or something. You do not have to use this as a basis for your password program. This one's like 90% done already. I would use this one. But this is a different approach. And in a way, maybe it's easier. Because all you have to do is copy and paste these functions and call it count digits, count specials and whatever, count lowers. And you could write your code that way. So that there's no main loop down here. All the looping is done in these functions. Are there any disadvantages to doing it this way? Well, if you're writing microcontroller, hardware that needs to run as absolutely fast as possible, you don't want to write all these loops where one loop would work, But Python is not a language for doing, that kind of stuff. So sometimes what's conceptually simplest for you is the right way to do it. And let's run it. I didn't test it yet. New password. I'm going to throw in some spaces and some uppers just to see if it works. Hello, there, friend, there. It ought to show 2 spaces and 3 uppercase letters. And it did. So you see how that could be used to do the same kind of rules, right? Oh, we forgot to check for length. Let's go back and add length. That's the last thing we forgot to do on our first password program. I mean, I could leave it for you to do by yourself, but while we're here, let's do it. So underneath if specials or up here at the top above if spaces, either place, we want to add one more thing. If len of password is less than or equal to our minimum length, which I think we decided was 7, you can change the rules, 8, 10, whatever you want. Print password must be at least 7 characters long. Oh, and we also have to set is valid. Is valid equals false. So if I type in 1, 2, 3, it ought to complain. that the password must be at least 7 characters long, and it did. So that part worked. I really want you to remember that function, len. Get the length of a list, get the length of a string, and it's pretty important. What else do I want you to remember? Is space, is upper, is alnum. If you go and check that Word document in our notes, sorry, I covered up our stuff. It's got all sorts of information on manipulating strings. How to compare strings. How to see if something is in a string. Check it out. There is a count option, but it doesn't really count all uppercase letters. It just counts a specific thing in your string. Like you could say how many X's are in it. That'd be great, but it wouldn't tell you all lowercase letters or how many uppercase letters are in there. Then there are some fancy ones like ends with. You want to find out if the sentence ends with the word whatever, or begins with the word how. You're writing, some Siri, hey Google type software, and you want to see if it begins with the word how, and if it's asking that kind of question. Or if it starts with, begins with, starts with. So do look at that document. It's not like I want you to commit absolutely everything in it to memory. The next time we hit these topics, I'll create a notepad of the stuff that I really want you to memorize for an exam. And of course, on the exam, you can just refer to this stuff. It's not to encourage you to skip memorizing them. All right. What do I want you to put in your Dropbox? Please put the password program we've written, this stringy program that we wrote, and the password 2 program if you completed it. Now the password 2 program is kind of the least important because your homework is not based on it. What did I do with it? Did I close it? And then I will post the instructions as a Word document for the homework, which is going to include the source code for password. If you want to do something else, if you want to use this kind of code instead, you don't have to use what you wrote today as the basis for this, but it makes it easier. Depends on whether you want to make it easier or not. So just asking, what do you think about doing it like this? Does this seem better to you, other than what I said about multiple loops? Easier to understand or harder to understand? This really does the same thing. It counts the number of spaces and the number of uppers, as our loop did in the other. Any opinions, or are you saying just shut up, Prof, and let us get out of here?
I like it better.
I kind of do too. It makes this part of the code cleaner. Hey, tell me how many spaces you got. Hey, tell me how many uppers you got. And in a way, the cleaner you make your code, the easier it is to understand, the easier it is for you and somebody else to maintain. But ultimately, conceptually, they're the same idea. You're still stepping through these things letter by letters with counters to determine the number of spaces. All right, guys. I think we're done for the day. Are there any questions? Which one do you need?
The password 2.
Okay, this is password 2. I can bring up them both. But we can't get the whole other one on the screen.